Hi, welcome. Today's lesson is on balancing equations. We've already been balancing equations in class, but all the equations we've been balancing are double replacement reactions. So first, before we do some other kinds, let's review that. So I have ammonium sulfate reacting with barium chloride, making barium sulfate and ammonium chloride. And all the formulas are correct. +1, -2, +2, -1, +2, -2, and +1, -1. So all the formulas are correct. And I didn't have enough room to put the aqueous right next to them because of my screen on my phone. So I put them underneath. So these are aqueous and barium sulfate is the solid. So let's balance this. I have 2 ammoniums on this side, only 1 ammonium on this side. So I'm going to put a 2 in front. I have 1 sulfate on this side, 1 sulfate on that side, so that's balanced. And I'm sorry for all the lines on screen, but it helps you to follow what I'm pointing to. 1 barium on this side, 1 barium on this side, 2 chlorides on this side, 2 chlorides on this side. So it's balanced. Very simple way to balance it. So I'm done with that one. Let's take a look at one that is not a double replacement reaction. So pause for a second and decide what type of reaction this one is. All right, I hope you guessed that it was decomposition. And if I go to balance it the same way as I did the last one, I'm going to have a problem. Because I start on this side and say there's 1 ammonium on the left, but I go to the right and there are no ammoniums on the right side. So I can't use the same technique as I did before. So instead of counting ions, since this is not a total, it's not a equation with 2 ionic compounds reacting to make 2 more ionic compounds, it's decomposition. There is no ammonium ion on the right side of this equation. So now I have to treat each element differently. So instead of looking at ammonium as a group, now I have to look at just the nitrogens, the hydrogens, the chromiums, and the oxygens. So I have to treat each element separately. So once I know that, it's really not too hard to balance. So I'm going to count again, but this time not the ions, but the individual elements. So on this side, I have 2 nitrogens, and I have 2 nitrogens on the right side. I have 4 times 2 or 8 hydrogens on this side, and I only have 2 here. So I need to put a 4 in front because 4 times 2 gives me 8. So I'm good with hydrogen. I have 2 chromiums right here. And on the other side, I have 2 chromiums. And I have 7 oxygens on the left and 4, 5, 6, 7 on the right. So I'm balanced already. So all I had to do was put a 4 in front of the water, and that's a balanced equation. So the only trick for that is to do the elements individually. So let's try another one. 1 bismuth on this side, 2 bismuth on this side. So I'm going to put a 2 in front. 2 oxygens here, but 5 oxygens here. We really haven't done much of a 2-5 combination, but what does both the number 2 and the number 5 go into? So pause and think about that. Hopefully you came up with 10. So to make each of these 10, I put a 5 in front of the O2 here and a 2 in front of the product. But when I put a 2 in the front of the product to balance out the oxygens, I also changed the bismuth. So now I have 4 bismuth. So I need to go back and erase this 2 and instead now put a 4. So remember, if you put something in front and you change something else, you have to go back and change that. So now it's balanced. 4, 5, and a 2 balances this equation. So not that difficult. What about a reaction that looks like this? So once again, pause it, figure out what type of reaction this is. Did you say combustion? That's right. How do I know it's combustion? Because I have carbon dioxide and water as products, And I also have some compound with carbon in it reacting with oxygen. So it is a combustion reaction. Now, combustion reactions sometimes can be difficult because of the oxygen. So if you look here, I have oxygen on the left side of my equation right here. But I have oxygen here and oxygen here. So oxygen is not on one side and the other side, it's in multiple places. So 1, 2, 3 places that I have oxygen. So that's going to make the oxygen difficult to balance. So if you ever have an equation where you have an element in more than 2 compounds, save that for last. So that's the trick. Write that down. I'm going to save the element that's in the most places for last. And in particular, I'm going to save to balance here, this one last. So I'm going to use this because it's all by itself, this oxygen. So if I change this one at the end, I'm not going to change anything else besides oxygen. I'm not going to change the carbons or the hydrogens. I'm just going to change the oxygen. So I'm going to save this for last. So let's go ahead and balance this, keeping this one here for last. So I have 4 carbons on the left and only 1 carbon on the right. So I'm going to put a 4 in front. I have 10 hydrogens on the left, 2 on the right. So I'm going to put a 5 in front of that. And now I have to go to the oxygens. So how many oxygens do I have on the right side? 4 times 2 is 8. 5 times 1 is 5. So I have 8 plus 5, or I have 13 oxygens on the right side. Now you go back and say, uh-oh, Ms. Backus, how can I do that? Nothing times 2 gives me 13. Well, if you think back to math, there is actually something times 2 that will give you 13. So I'm going to let you think about it and answer that. So did you come up with it? What times 2 gives me 13? Well, you could have said 13 halves. Or 6.5 times 2 will give me 13. But half of a molecule? Well, we don't usually like to leave halves when we balance it. So we're not quite done yet. We're going to get rid of this 2. To do that, I'm going to multiply everything by 2. So how does that work? So I'm going to go from the beginning. I'm going to multiply this by 2. I'm going to erase this and multiply 13 halves by 2. And that gives me 13. I'm going to erase this. 4 times 2 gives me 8. And 5 times 2 gives me 10. So I'm going to erase that and change that to 10. So let's see if that really did work. So let's count again. I have 8 carbons on the left, 8 carbons on the right, 20 hydrogens on the left, 20 hydrogens on the right. I have 26 oxygens on the left and 16 plus 10 on the right, which also equals 26. So it is a balanced equation. So in review, how am I going to balance these equations? 1, if I see an element in more than 2 compounds, I'm going to save it for last. And if it exists all by itself, I'm going to save that one for last. If I ever have to take half, like if I need to have something multiplied to be an odd number, I need 13.5. Go ahead and put that down, but don't leave it like that. Go back and multiply to get rid of the denominator. So I multiplied everything by 2. All right? So let's try another one. And that's about as hard as you're going to get when you're balancing. So let's try this one. Notice here I have 1 rubidium on the left, 1 rubidium on the right. Hydrogen on 1 compound on the left and hydrogen in 2 compounds on the right. So hydrogen appears in 1, 2, 3 compounds. So I'm going to save that for last. Oxygen only appears once on the left and once on the right. So I'm going to save this one and balance this at the very end. All right? So 1 rubidium on the left, 1 on the right. It's already balanced. All right? I'm going to skip the hydrogens. I'm saving that for last and go to the oxygen. 1 oxygen on the left, 1 oxygen on the right. Now I've got to balance the hydrogens. I have 2 hydrogens on the left and 1 hydrogen here, and then I need just 1 more hydrogen here to give me 2. So I'm saving this one to change this spot last. So if I could make that multiply something by 2 to give me just 1, I would balance that. Well, what times 2 gives me 1? 1/2. So once again, I've got it balanced, but I don't want to leave it as a half. I'm going to multiply everything by 2. So I'm going to erase this and make this 2 times a half is 1. This was a 1 here before, so it's now 2. This was a 1 here before, so it's now 2. This was a 1 here before, so that's now 2. So 2 rubidiums on the left, 2 rubidiums on the right. 4 hydrogens on the left, 2 plus 2, 4 hydrogens on the right. 2 oxygens on the left, 2 oxygens on the right, and that's balanced. You won't have a lot of these, but you will have some of these. So once again, if you see an element that appears in more than 2 compounds, save that one for the last. And especially save it, the one that's all by itself, for the very, very last one that you balance. If you need to take a half or 3 halves or 5 halves or 10 halves, well, not 10 halves, 9 halves of something, go ahead and do that, but then at the end, multiply everything by 2 to get rid of that half. All right. The best way to learn these is give them a try yourself. The answer keys will be online, and I'll be there in class to help you out. So thanks for listening.